In this video, we're going to discuss the vertex of quadratic functions. Now, in the previous sections videos, we had talked about quadratic equations. So the difference between an equation and a function is that a function has an independent and a dependent variable. So if you look, this first one I've written here, I have ax squared plus bx plus c, which is the standard form for a quadratic equation, and it's equal to 0. So this is merely an equation. We have one variable, x. Now the second line here, this is a quadratic function because we have an independent, an input variable x, and an output or a dependent variable y, or rather f of x. So when we are dealing with a function, something with an x and a y, or f of x, that means we can graph this in the Cartesian plane. But really, what I was just trying to differentiate here is this top line represents basically an equation with one variable x. And the second line that I've drawn is a function because we have an input x and an output y, or f of x. So we have an independent variable and a dependent variable. The output depends on what the input is. As we talk about graphing quadratic functions, one thing that we have mentioned before and we should know is that the graph of a quadratic function is called a parabola. And a parabola is generally drawn as this upwards U or downwards U shape. So all parabolas, they're always going to be symmetric, and they're going to be that U either with both ends opening up or both ends opening down. So all parabolas, all quadratic functions, are going to be shaped in either of these two manners when we graph them. And as we talk about the max and min, the extreme value for a parabola, that max or min will always occur at what is called the vertex. So the vertex is the turning point for any quadratic function. And they're only going to have either one maximum, this high max value, or one minimum, this low y value. So a parabola will always have one vertex, a max, or a min. And if your quadratic function is written in standard form, f of x equals ax squared plus bx plus c, then the vertex, that high or low point, will always be found by using this formula. So the vertex is a point, it's an ordered pair. What you see here is essentially some x value and some y value ordered pair. And what we do is we calculate the x value. We say that x is negative b over 2a. So we calculate that x value. And whatever we get for that x value, we then take negative b over 2a and we plug it into the function. So my y is the function evaluated at negative b over 2a. So the main thing that you want to keep in mind when you're dealing with a parabola is to find that vertex, that max or min value. You're going to calculate the x and plug it in to the function to find the corresponding y. Remember, the y value is dependent on the x value. So x is always calculated by negative b divided by 2a, and that b and a are the coefficients of my linear and quadratic terms in that quadratic function. And we also need to recognize that quadratic functions, their graphs, which are parabolas, these parabolas are symmetric. So they will always have a vertical axis of symmetry. Now that axis of symmetry is a vertical line. The equation of a vertical line is x equals a number. Well, when that vertical line passes through the vertex, we know what that number is. It's the x value, negative b over 2a. So when we are trying to calculate this axis of symmetry, we just always make sure that we use this formula, x equals negative b over 2a. So the main takeaway here, the thing you need to store in your brain, is that when you're asked to find a vertex or an axis of symmetry, the axis of symmetry is calculated by x equals negative b over 2a. This needs to be memorized. And then in order to find the y value of the vertex, you're going to take that negative b over 2a for x and plug that into your function to get the output. Let's expand on what we know about parabolas before we do our example. So we're going to learn one more thing. Also, in the previous section, we talked about putting quadratic functions or quadratic equations into what is called vertex form, or this transformation form. Now, we have already learned about transformations in this class. We used the letters A, H, and K. So the vertex is actually the H and K value, my horizontal shift and my vertical shift. So if we have a quadratic equation in this form, it's very easy for us to choose that vertex. Also, if you recall, the A value, that had to do with vertical shrinking or stretching. But also, if A was a negative value, we could have a vertical reflection across the x-axis. Now, if you think about having a parabola that opens up and you reflect that down across the x-axis, it would be symmetric, which my drawing isn't perfect here, but it would be opening down. So what that lets us know is that if the A value is negative, if we have a negative A value, then the graph will open down. So a negative leading coefficient, A being less than 0 means negative. That tells us the graph opens down like a frown. And if the graph opens down, the maximum is going to be at that vertex. So that vertex is a high point. That is a relative maximum. Similarly, if the leading coefficient, if that quadratic coefficient A is greater than 0, that implies positive. And if it is greater than 0, there would be no flip. So we would say the graph opens up. So the graph opens up like a cup. And if it opens up, that vertex is going to occur at the minimum. So if the A value is positive, the graph opens up like a cup and has a minimum value at the vertex. So we say down like a frown, spills water, up like a cup, happy holds water. You'd be sad and you'd frown if you spilled your water. And just a reminder, when we talk about relative extrema or max or min values, we always say that that max or min is the y value, so the y value is the maximum, and it occurs, the location of it is at the specific x value, so x equals some number. All right, let's do one short example. For the example, we are given the function negative x squared plus 5x minus 9. Now, negative x squared, we have this x squared term that lets me know I'm dealing with a quadratic and it's a function because we have an output or a y value. The first thing we're going to do here is to find the axis of symmetry. And by definition, the axis of symmetry is found by calculating x, and x is equal to negative b over 2a. So now my A value, A here is negative 1/2. My B value is positive 5. So B, there's a plus in front of that 5, it's positive 5. So now we have X equals negative 5 divided by 2 times my A value, which is negative 1/2. If I look at simplifying this, I have negative 5 over negative 1, or rather 5. So my axis of symmetry is x equals 5. Part B of this problem, we're going to find the vertex. Now, the vertex is the max or min, the high or low point, which is passing through that axis of symmetry. So we know the x value. The vertex is a point on the graph or an ordered pair. In order to find the output y, I'm going to plug the 5 into the function. So what we would have would be f of 5 is negative 1/2 times 5 squared plus 5 times 5 minus 9. So we have negative 25 over 2 plus 25 minus 9. That gives us an output of positive 7/2. So the vertex, which is an ordered pair, is going to be written as 5, 7/2. Right? So always making sure when we state that vertex that we write that as an XY ordered pair. So we know the axis of symmetry and we know the vertex. So let's take this information and extend it back to talking about relative extrema. Does the graph of this function f of x have any relative extrema? And then if so, we're going to state that extreme value. Let's think about what we know about quadratic functions. We are dealing with x squared, which means the graph of this is a parabola either opening down or opening up. And how do we know which direction the graph is opening? Since that leading coefficient, a, which is negative 1/2, is less than 0, that lets me know the graph opens down. So we have a parabola opening down, and what would that indicate about the vertex? Would the vertex represent a max or a min? And in this case, since it opens down, the vertex is a max. So remember, the max or the min is y, and the max or the min occurs or happens at some x value. In this situation, we will say the max, the relative maximum, is 7/2, and then it occurs at x equals positive 5. That would be our last third piece of the answer here. So the maximum is y, which is 7/2, and that it occurs at x equals 5. So this last piece wasn't really new information. It was a little bit of review, and we're synthesizing that together with the vertex. The main thing we know is that the vertex is always going to represent a relative max or a relative min for any quadratic function. And that's going to be a hint for us, especially when we move forward and we have application problems. If you are asked to maximize or minimize to find that maximum or minimum value for some function, you're really just going to be using this vertex formula. So as long as you can determine what B and A are, you'll always be able to solve these maximum and minimum problems when we're dealing with quadratic functions. As always, feel free to reach out if you have any questions or concerns.